Hey everybody, it's Tom Cherryholmes with the FujiNet project, and I wanted to do a quick video because someone had made the comment that the ability to use Fortran on their Ataris was just over the horizon, and I wanted to demonstrate how true that statement actually is. And so we're going to take a little program that I've whipped up in Fortran, just a simple prime number benchmark, and we're going to take and compile it. We're going to look at it, then we're going to take and compile it, and then we're going to link it and run it in CPM here. I'm using DT80, which is an ADM3A terminal emulator for originally for the ATR 8000, but it works well with the FujiNet here with the modifications that I've done. So we'll start by basically going over onto drive E, which contains my copy of WordStar 4. And I will load WordStar. This is a version of WordStar version 4. I'm using this one because WordStar 4 added the ability to more easily traverse different user areas, which really wasn't all that easy under WordStar 3. We go into here and we log onto my drive F, which contains my Fortran compiler, but my Fortran compiler is not on user area 0, it's in user area 1, so I need to go to F1. And we see right here that we've got some files that we can deal with here. And I'm going to open a non-document file for prime.4. We can see the listing of the files underneath. I see it's there. Go ahead and load it. And within a few moments here, it loads the other section of WordStar and then loads the document. And we can see right here, this is essentially a prime number benchmark. We take and set up some variables. We take and write some sign-on messages. Then we enter into a loop where we take and divide numbers together and find out whether or not they are prime numbers or not by using a series of ifs here, continuing on as we need to, and finally writing out the results with the messages down here and their own line numbers here and the end of the program down here. Pretty simple, and if you're not really used to Fortran, it can be a little strange because unlike BASIC, you don't have to have line numbers on all of the different lines, and there's not really, in classic Fortran, there's not much in the way of structure. Let's just put it that way. It's a little odd, but it has its own charm once you get to know it. So we'll go ahead, we won't do anything to this file since I've already made all the changes and debugged it, make sure it's okay. We'll take and quit. Come back into WordStar for just a moment, and then exit. At which point I can then go to drive F, go to user 1. I'm going to do a little bit of cleanup here for things that I know that I have here. Do I have any backup files? Nope. Okay. So here's our Fortran compiler right here. And this is Microsoft's Fortran 80 compiler. That means that unlike most of the other Microsoft language products, it consists of the language itself. It consists of the linker, and usually it came with a copy of Macro 80 as well, which is m80.com right down there, so that you could write assembly language routines to link into your programs that you were developing in your languages. So you could do things that were not normally in the standard library. In our case, we just want to take and compile our prime 4. If we take and type our prime 4 here, which is right here, we can see the program that we've written. Okay, great, that's cool. And then we can start F80 to take and compile the program. And since this is a single source, there's only a simple command that we need to do to generate the initial object file. And that is to specify a destination and the source, both separated by an equals. The program is compiled very quickly, and we wind up with this isn't a finished product. We have to hit Control-C to get back to the CCP. And if we take a look at what got generated, we can see that we have our source file, but we also have a relocatable object file. We can't run that because the addresses that are inside this file basically start at 0. They're relative addresses from the start of this particular program segment. So we have to run this through the linker, which will take and search this drive right here for additional files, libraries, etc., that it can link against to resolve the missing symbols and finally assemble the whole program together at an absolute location in memory and save the result out to a file that we can run in CPM. So we use L80 to do this, and we need to specify both the source and the destination. And to make things easy here, since we're only really linking this one thing, we want to go ahead and produce the final output, and we want to exit once we're done. Now, you don't see anything happening here, and since this is all virtual, you're not hearing any disk drives whir in the background, although that might be an interesting possibility later. But what's actually happening here is it is now looking through the forlib and resolving the symbols in that forlib and producing the final memory image. We can see that after we've done this, we're left with 40K bytes free. And if we now look, we now see that we have our source code, the relocatable object file, and our prime.com right there. To give you an idea of the size of these files, we'll use stat here to take a look at them. And you'll see that first and foremost, CPM disk usage can be rather wasteful on larger drives here. You can see the files are taking up a minimum of 4 kilobytes of space, but there's only a handful of records here. So we're looking at maybe the relocatable object file is maybe a K.5 in actual size. Similar with the Prime Fortran source code, but the prime.com is almost 8 kilobytes in size because of the routines that were linked in from the standard library. Let's go ahead and run it. And you'll see right here one of the interesting disparities of the run CPM implementation. That should give you an idea of how fast this the Z80 is running on the ESP32. Because on a real Z80, on a 2 megahertz or a 4 megahertz Z80, it don't run that fast. So this is the CPU is running, I'd say, God, close to 1,000% faster, maybe faster at least. The bottleneck, of course, is the disk I/O functions, which I'm working to optimize here. But let's go ahead and run that again. Boom. And there we go. So, run it again. So there we go. We've gone through the process of taking a piece of Fortran code, compiling it, and linking it together. So, yes, Fortran on Atari. Possibility. Until next time, guys. Have fun.